Welcome and thank you for joining me, Ms. Trott, once again for Math and Science for Young Children. In each of our sessions, we will be reviewing math, science, and early childhood topics. Our goals for this session are to understand the concepts of mathematizing and binary sort, appreciate the importance of embedding math and science learning in children's prior knowledge and real-world contexts, and deepen understandings of science process skills appropriate for young children. Make sure you download the note sheet to go along with the video and stick around as we learn more about science and math for young children. Remember, in this course's philosophy and teaching approach, adults also need hands-on, experimental learning. Learning is doing, and it is important at any age. It is important for teachers to play and explore materials themselves, and having these experiences will help guide your students. And learning from each other is as important as learning from me, your instructor. One of the most effective ways to help you learn how to successfully translate what you learn in this course to young children is through instructor modeling. So I will be modeling experiences and demonstrate activities much as they would be done with children. And then you're going to take on the role of the child first and then reflect on the experience and the content of the classroom implementation. And these experiences help you better understand the concepts from both the perspective of the child as well as the teacher. The purpose of instructor modeling is a way to help you successfully implement novel teaching practices and techniques more effectively with children. There are many ways to sort, and a binary sort is one of those ways. This is when you take a set and it's sorted into two groups. One group showing the characteristics and the other group not showing characteristics. So an example of this might be everybody stands up, and those who have blonde hair are in a set, and everybody else with color hair other than blonde are going to be in that other set. That's a binary sort. The term mathematize is used when talking about the importance of helping children engage with mathematics that is all around us. And activities involving student names is a great example of mathematizing the world around us, when we're able to point out math concepts in their everyday worlds. There's a website that we will be referencing throughout this course, and it is called the Erickson Early Math Collaborative. And this is a great website where you can find articles and activities and videos about all different math concepts with young children. I encourage you to use the idea library found on that site to learn about research, get curriculum ideas, and watch videos that demonstrate effective practices in teaching early math. I hope by now you've at least accessed the Alabama Standards for Early Learning Development and reviewed the guidelines to go along with teaching math and science and technology to young children. There are many science process skills that students will learn in the early years. These skills are practiced in all science disciplines: physical science, life science, and earth science. There are 11 science process skills that we will be talking about throughout the course for early childhood education. Science process skills, also called science practices, are the skills that scientists use in the process of doing science. These are actually the same skills we use in all of our daily lives as we try to figure out everyday questions and interact with the world in a scientific way. Science skills are usually integrated together or used alongside one another. So let's quickly review our science process skills: observing, asking questions, comparing and contrasting, classifying, predicting, experimenting, using simple tools to observe and gather information, measuring, drawing conclusions, communicating, and using and creating models. Each week we will be conducting an experiment, and you will notice different science process skills being involved in the different experiments that we complete. It's important to note that when we talk about math and science concepts, while we do activities that children would be doing, we also provide you as an educator background information. So it's not necessarily things that you would be teaching the children, but it helps you with your confidence in teaching the subject matter. Our science focus for this session is water. Water is everywhere in oceans, lakes, rivers, streams. It comes from the sky as rain and snow. It is essential for life. Water is interesting for children to explore, and they love to play with water. Even though we interact with water every day, we rarely take the time to experiment and use different types of materials and tools to really explore and to think about all of the interesting properties of water. Think about it. How have you used water today? There are a couple concepts associated with water that we need to know about. The first is that water's movement is generally described as flow, and water flows down due to gravity. This can be seen in many different ways. Rivers flow from higher places to lower ones. Drops of rain flow down the window panes. Streams of rain flow down gutters and downspouts, and water poured slowly from one cup to another will flow to the lower container. Water can also be made to move up when force exerted is stronger than the downward pull of gravity, such as when you push on it to squirt it out of a dropper or a syringe. Air pressure can push water up when you squeeze and let go of the bulb of a turkey baster or an eyedropper, or when you suck on a straw. Water moves faster or slower depending on the strength of forces acting on it. Another note about water is that it takes the shape of its container. Water does not have a fixed shape and is constantly changing to fit its shape to the space available. So when water is in a cup, it's going to take the shape of those items. And the surface of the water will be flat unless it's moved by something else, like wind. The behavior of air in water is that air takes up space and air bubbles float to the top of the water. Both water and air take space, but in order for water to fill an empty, it must take the place of the air that was already in there. When pouring water into a cup, the water easily replaces the air. But if you put a cup underwater with its open end down, you have to tip it up to let the air out so the water can get in. You can see the bubbles of air come out. Since air is less dense than water, those bubbles will quickly float to the top of the air and pop. Make sure you do the water activities and then think about the following questions. How did you use science process skills during your water exploration? What kind of math learning might children have experienced during this water exploration? What insights did this experience give you about doing water play exploration with children? Please be sure to complete all of the activities posted in your course so that you can get more background information on these subjects as well as getting some experiences. If you have any questions, feel free to reach out me, Miss Trott, or your instructor. And I can't wait to see you next time as we learn more about math and science for young children.